Okay, hi, so in this video we're going to speak a bit about the national grid. Now the national grid is how we all get electricity to our homes. Because if you think about it, the electricity is being produced in one power station or another, but it needs to be able to be transported to our homes where we need to use the electricity. The way that's done is via the national grid. Okay, now the voltage of the national grid is 132,000 volts. 132,000. So that's the voltage of the national grid. Now the voltage that we use in our homes, so our mains, is around about 230 volts. Okay, so at home you get 230. There we go, national grid there. And it's produced, so at the power station, the electricity is produced at around 25,000 volts. So you can see that the voltage actually changes from the power station to the national grid and then to our homes. And how it does this is via a device known as a transformer. No, these don't look like cars which can transform into giant robots, but these are devices which can change the voltage. And you have two types. One is known as a step-up transformer, and the other one is known as a step-down transformer. Step up just means it's going to rack up the voltage, so the voltage will go up, and step down, of course, the voltage will go down. So if we start at the power station and then we are transferring to the national grid, this will be a step up transformer that allows that because it's upping the voltage. From the national grid to our homes, we need to then step down the voltage, 230, and that is exactly what we do with a step down transformer. Now you've probably seen these pylons, which are what we use to actually allow the electricity to be transported. What we have is these pylons, which are joined by these huge cables. They're not actually purple in real life, but this is just so you can see them. These cables actually transport the electricity. Now these cables are very thick, and they will be carrying the 132,000 volts of electricity. The reason why we use such a high voltage is because high voltage reduces the energy loss, so equals lower energy loss. So we want to be as efficient as possible when transporting the electricity, and the way to do that is to put it at a very high voltage. Now if we go even higher and higher and higher, then that will become too much and it won't be viable. So this is almost like a compromise, but it is a very high voltage, so that reduces the energy loss. Well, you might think, well then why do we bother reducing it at all? Well, 132,000 volts would be extremely dangerous. If you got an electric shock from that, then it's going to do some serious damage. And so that is why we need to bring it down to a safe level. So 230 volts is a compromise. Okay, now let's have a look a bit more in detail about why stepping up the voltage is going to reduce energy loss. So if we take a look at this cable here, then what's actually happening, we're going to zoom in. We have the cable. Okay, let's say this is the inside of the cable. What you've got are electrons which are buzzing through, and this collectively is known as the current. Okay? The current is basically how fast these electrons are buzzing through the wire. Just like the current of a river is how fast the river is flowing, how fast the water is moving, the current here is how fast these electrons are moving. Okay, and now the voltage is how much energy each one of these electrons have. So if these electrons are absolutely buzzing with energy, then that means you have a higher voltage, okay? The current tells you how many of those electrons are moving, okay? So voltage is energy per electron, if you like. Okay, this is a slight simplification, but it's useful in this example. What that means is that our power, let's do that in a different color as well, our power is actually our voltage and our current. So our voltage and our current, both of those will affect our power. Now it's actually our voltage times our current. So that means if we want the same amount of power, if we increase the voltage, that means we can reduce the current. What's actually happening in terms of energy loss is the faster that these electrons are moving, the more friction there is, and therefore the more heat is given off. Okay, so high current equals high energy loss. Now, if we can get the same amount of power by reducing the current, then that means that we are reducing the energy loss. So what we do is we increase the voltage, and that means that we can decrease the current, giving us exactly the same amount of power, and that equals decreased energy loss. Okay, so just by utilizing that, it means that we can reduce the amount of energy that's lost and making us more efficient at transferring energy via electricity, of course. Okay, now one last thing is it's important to realise that while we can see these pylons here are above ground and they're running cables above ground, we can also dig down deeper and run these cables underground. And so there are various pros and cons for both, and I'm going to have a look at the positives of both. And so underground cables, well, you can't see them. So no visual pollution. A lot of people think that the overground cables and the pylons look awful and they ruin the environment, and so this avoids the problem. Also, animals can fly into them. Birds especially can fly into the overground cables and obviously get electrocuted. So birds cannot fly into them, so into the cables if they're buried underground. Now, when you have an electric field, so a strong electric field associated with these cables, you also have with it a magnetic field. Many people believe, or some believe, that this is dangerous to the health, and so underground people think will produce a lower magnetic field. So some believe produces a lower or a smaller magnetic field. Now, on the other hand, if you build cables overground, then it's easier to install. So easy, or easier, and cheaper to install. This is because to build underground cables, we have to dig the whole of the land up and then run the cable through the entire of the land. Whereas with pylons, you need to build one pylon and then another pylon, and the cable will run through the middle of them. So you don't actually have to dig a hole throughout the entire stretch. You just need to build the pylons. This also means that they are easier to maintain. Because if you've buried a cable underground and then it goes wrong, you've got to dig it up again to try and fix the problem. Whereas one which is above ground, you can spot the problem and just get an electrical engineer to go up and fix the problem. Now, while some people think that the magnetic field is going to be reduced underground, others think that, well, above ground, they are high up. So they are high up, whereas underground, we are not going to dig down, hundreds of feet underground, and so the cables will actually be closer if they're underground. So high up equals further away from potential harm. So from harm. Okay, so they're two very opposite arguments. And lastly, there are more places we can put the overground, because if we have a river, rivers, streams, and of course also traffic, so roads, it's very, very difficult to dig under these and run an electric cable through them. Whereas overground cables can go either over the top of the roads, over the top of the rivers and streams, or alongside them, and it means that we can build them in more places. So we can say suitable to a higher number of environments. Okay, so I'm going to stop there. That was just a brief overview of the national grid. You need to be able to argue the underground and overground. It's up to you to decide which one's going to be better, but you need to know the pros and cons of both. Make sure that you know what a transformer is in terms of a step up and a step down transformer, and why we're going to raise the voltage in order to run the electricity from the power station to our homes. Okay, so if you do have any questions on that, please feel free to send me a direct email using the link below, or post a comment in the comment box, and I look forward to seeing you in the next video.